All right, class, hopefully you had a good week and a good Easter. I'm actually recording this ahead of time, so Easter has not quite taken place yet. And we're planning to go to the drive-in service, so that will be interesting, and hopefully that will go well. You know, nothing more important than Easter and the resurrection. And you know, in the days and times that we live in, I hope that you're 100% sure that you're born again. Nothing more important than securing heaven as our home. And that's only through trusting in Jesus Christ as your Savior. For by grace are you saved through faith, and that not of yourselves. It is the gift of God, not of works, lest any man should boast. And so I trust that you've trusted Him, that you're born again, and nothing more important. All right, let's get into this review and see how well you fared. A couple important things here, so let's see as we go through. All right, number 1 and 2 says mentally estimate each root to the nearest integer. All right, so here's what I'm trying to think of. The square root of 127. Now, I know the square root of 81 is 9. The square root, excuse me, of 100 is 10. The square root of 121 is 11. And I know the square root of 144 is 12. See, those are the two integers. And so 127 falls between 121 and 144. And it says to the nearest integer. So 127 is a lot closer to 121 than 144. So I would estimate that at 11. Now, if I were going to round it to a one decimal place, I don't know, I'd say 11.1, 11.2. Right, on number 2, it's a cube root. So this is a little bit different. So here's your logic. Let me just do some you know. The cube root of 8 is 2. The cube root of 3 times 3 times 3, or the cube root of 27, is 3. The cube root of 4 times 4 times 4, or 64, is 4. And notice this 50 is between the 27 and the 64. It's actually closer to 64, so I would estimate 4. If they were looking for one decimal place, I'd say, I don't know, 3.7, 3.8, somewhere in there would be my estimate if I were estimating. Okay, that's just to give you a general idea, see if you understand what radicals are. All right, use a calculator to approximate each radical to the nearest hundredth. Boy, if you miss these, it's just punch in your calculator. 0.63 square root button, and it says hundredth. So 0. There's the 10th. Hundredth. I'm just going to show you my calculator. So I'm going to have to round to the hundredth place. So that goes from a 9 to a 10. That goes to a 4. So you should have gotten 0.04. All right, and something's off there. Let me see. Maybe I punched in the wrong number here. 0.63. Don't you love it when you punch in the wrong numbers? Okay, let's fix that. And here's what I got. Let me show you my calculator. 0.07937, etc. Round to the hundredth. That's the decimal place. The 3 is not 5 or above, so I leave it 0.79. All right, and then 619. So it's cube root. So you have to know how to punch in a cube root into your calculator. And so punching that in, I got 8.5224 ... And so checking that out to the hundredth, that would be 8.52 would be the, and usually you give like the, oh, that's a bad wavy equal sign for approximately, right? 8.52. What's your cube root button? For my calculator, I had an x, the x root of y. So I punched in the 619, then I hit this button, then I put the 3 in for the index. That's how I did it on my calculator. Every calculator is going to be a little bit different. All right, and look, if you don't know how to do your calculator, just Google it. You know, in these days, say the model of your calculator, Google your question, how do you take a cube root, and you'll get it in just a matter of seconds. All right, convert each radical to exponent form. It is very important that you understand how to convert a radical to exponent form. Now, in both of these instances, first off, you must understand this is a 2 times an x cubed. In addition, the index of 2 is not shown. In addition, the 1 has a 1 exponent that's not shown. So I get 2 to its exponent over the index, so 2 to the 1/2, times x to its exponent over the index, x to the 3/2. Now they're not looking for you to simplify, so that would be our final answer on that. 2 to the 1/2, x to the 3/2. So on this one, do you understand the 3 has a 1 exponent, so 3 to the 1/4 times y to the 2/4, and that we have to reduce, right? So 3 to the 1/4, y to the 1/2 should be your final answer. Always look to reduce all fractions. Okay, so it's important that you understand how to convert. This is going to help in your understanding down the road. Now in these, we want to go the other way. We want to go the opposite direction. And again, so let me show you the rule. So let me do this with some color. Let's go with what, b here, and let's go with x to the a. And so what does this equal? X to the a over b power, right? And that's what we just did a moment ago. We converted from this to this. That was questions, what, 5 and 6. So 7 and 8 want you to go the opposite direction. Go from this back to that. All right, and again, this just helps in your understanding of what's going on. So notice where the index is. These 3's are my index, right? And then what do I have? I have 3 squared times a to the 5th. 3 squared times a to the 5th. And in addition, so there's a couple other things going on here. I should turn this into a 9. Now this is a little bit off, but this a to the 5th can be simplified, right? Isn't this an a cubed times an a squared? And what is the cube root of a cubed? It's an a, and you get an a out. So what's the final answer? A times the cube root of 9a squared. Now again, it was a little tricky because you could simplify that a. All right, the same thing's going to happen here with these z's. Look at that, z to the 4/3. Well, we already know, therefore, then that's z times z to the 1/3. Would you agree? So I'm doing this one a little bit different way. Z to the 4/3 is z to the 1 times z to the 1/3, right? So this, we don't have to change, it just stays z. Now, here you got a couple things going on. So this one's got a bit going on here. Look at this part. This is 16 to the 1/3 times x to the 1/3 times y to the 1/3, and then we still have this z to the 1/3. Okay, notice these are all 3's. Now if they weren't, we'd have to get a common denominator so that we can get the same index. But they're all 3's, so we're good. So that's my index. Notice this z is still out in front, right? I have a 16 to the 1, x to the 1, y to the 1, z inside to the 1, right? And that's the answer there. However, once again on the simplifying, what is a 16? So 16 is 2 times 8. What is the cube root of 8? The cube root of 8 is a 2, so I get a 2 out. So final answer, 2z times the cube root of 2x, y, z. It's this simplifying where students tend to struggle, but you always have to look for it. You always have to look for it. Now you might say, what if I didn't know to do this in the beginning? Okay, that's fine. Let me show it to you that way. So you didn't do this in the beginning, right? So I won't do it. So I won't put that there. Just leave that there for a moment. This is going to be to the 4/3, right? And therefore then this would be to the 4/3. And then right here, I would be saying this is a z cubed times a z. And then I would say, what's the cube root of z cubed? Again, notice how the exponents match in the index, and that's a z. And I got a z out, and notice I end up in the exact same place, 2z times the cube root of 2x, y, z. Now look, it's important you understand how to do these things, how to convert, because it leads to your understanding of what's going on with radicals. All right, let's keep going. All right, simplify. If the expression is not a real number, state not real. Do not assume that variables in the radicand are non-negative. Okay, so we have to be careful. You cannot take an even root, that's a 2 index, 4 index, 6 index, 8 index. You cannot take an even root of a negative radicand. For example, the index here is 2, it's not shown, and we have a negative radicand. This is not real. So, and I think that's what they want you to say, right? Yes, say not real. So number 10 is not real. However, look at number 9. That is an odd index. No problem there. So this is important to understand. What does a cube root mean? What number times itself 3 times is negative 8? Well, a negative 2 times a negative 2 times a negative 2 equals negative 8. So what number times itself 3 times is a negative 8? And the answer is negative 2. So the cube root of negative 8 is negative 2. All right, look at number 11, simplifying. So look, I know this is an index of 2. So I'm looking for a number times itself. All right, 84. 2 times 42. 42. 2 times 21. Do you see now how I have a 2 times a 2? Which, by the way, is a 4. But what's the square root of 4 or the square root of a 2 times 2? Well, you get a 2 out. So this is out. We still have a radical. Notice the 21 is still in. And again, notice the little things that I do just to keep track of things. Notice I cross everything else off once I use it. The 84 became a 2 times 42, so I crossed off the 84. The 42 became a 2 times 21, so I crossed off 42. The 2 times 2, I took the square root of, so I crossed them out because I took the root of them. What's left in a 21? Now look, you can change 21 to 3 times 7, but you only have 1 3, and you only have 1 7. So you don't have enough 3's to get 3's out, you don't have enough 7's to get 7's out, so it stays 21. And that's why number 11 was 2 times the square root of 21. All right, let's look at number 12. All right, this is a 5th root. Boy, we need 5 of something. All right, I'm looking at my index. I need 5 of these. I'm just going to start factoring. 2, all right, 1728. I'm just going to grab my calculator. 1728 and divide by 2. Okay, it says 864. All right, let's divide the 864 by 2. What do you get? 432. Let's divide the 432 by 2. I'm going to do that. My calculator, I don't want to make a mistake. 216. Okay, I only have 3 2's so far. 2 into 216 is 108. 2 times 54 is 108. Okay, right now, 1, 2, 3, 4, 5. I have 5 2's. What's the 5th root of 2 times itself 5 times? I just got a 2 out. Now, can I get some other numbers out? I don't know. I got to check. 54. 6 times 9. A 6 is a 2 and a 3, and a 9 is a 3 and a 3. Okay, I only have 1 2. That's not enough. I only have 3 3's. That's not enough. Can't get anything else out. So it's going to be 2 times, don't forget your index, the 5th root of 54 of 2 times 3 times 3 times 3 was my 54. So number 12, 2 times the 5th root of 54. All right, 13. Are you aware of your 2 index? We'll do our numbers first. A 12 is a 3 times 4. And we should all know the square root of 4 is a 2. I'm getting a 2 out front, right? Because a 4 is a 2 times 2. Now, a cubed, that's an a squared times an a. What's the square root of a squared? Anything times itself, the square root is it, so I get an a out. B squared, you can do it two different ways here. Let me use a different color here. I'll use black. You can think of a b to the fourth two ways. You can think of it as b squared times b squared. What's the square root of b squared? B. What's the square root of b squared? B. Now, and you say, well, what's the other way? Well, I could have just thought of it as a b to the 4 divided by 2, which is indeed a b squared, right? Same thing? Okay, so anyhow, those are the two ways there. Now, what's left inside? We've got the radicand. I've got a 3 left in. You got to be neat here that you don't lose stuff that's left in an a. All right, let's clean up our answer. 2a b squared times the square root of 3a. You must be able to do this. This is the key of everything we do with radicals, because everything we do, we've got to simplify. If we're adding radicals, we got to simplify. If we're multiplying radicals, we got to simplify. If we're dividing radicals, we got to simplify. If we're subtracting radicals, we got to simplify. If we're doing radical equations, we got to simplify. If we're doing the Pythagorean theorem, we got to simplify. Everything we do with radicals, we have to simplify. So you got to know how to simplify. You got to get this lesson down. You gotta. And look, if you're not, watch the quick review videos. Go on to www.afterschoolhelp.com and get this figured out. It's the key to radicals. You got to understand how to simplify them. Okay, 14 is a cube root. Now I need 3 of something. All right, let's do this 81. 81, 9 times 9 is 81. There's 2 9s, but I need 3 of something. All right, this 9 is a 3 times 3, and this 9 is a 3 times 3. Okay. I'm going to take 3 of the 3's. The cube root of anything times itself 3 times is itself. I have a 3 out now. X squared. I don't have enough of any of the x's. I only have 2. I need 3, so they're all staying in. Y to the 4th. Let's change it to a y cubed times y. Isn't that y to the 4th? What's the cube root of y cubed? Y. What's left in? Don't forget your index. The cube root. I have a 3 left in. I have an x squared left in. This is where you got to be neat. And I have a y left in. There's my answer. 3y times the cube root of 3 x squared y. Real important. Okay, assume that variables here. Let me use my shade right here. Keep you focused. So assume that all variables in the radicand represent non-negative values. Okay. So here we have multiplying of radicals. Now, let me remind you, the indexes must match to be able to multiply. They match. Both are 3. So 15 we can multiply. 16 we can multiply. They're both square roots. And 17 we can multiply. They're both square roots. Now, technically, the rule is that you put them all under the same radicand, right? That's the cube root of a 21 times a 9. Now again, I got to look to simplify. I don't want to just grab my calculator and do 9 times 21. That's foolish. It's going to waste my time, because how do you simplify? By factoring, by unmultiplying. So you don't want to multiply the 9 times 21. All right. 21, 3 times 7, 9, 3 times 3. Now I'm always aware of my index. I need 3 of something. There's 1 3. And there's 2 more. I have 3 3's. The cube root of 3 3's, I get a 3 out. What's left in? The cube root of 7. So number 15 is 3 times the cube root of 7, and that's why the back of the book had that answer. Now, I told you guys you can SBUM, simplify before, yeah, that's not SBUM, SBUM, there we go. Simplify before you multiply, because they're all going to end up underneath the same radical. So I'm going to think about this 8 as a 2 times 4. I'm going to think about the 18 as a 2 times 9. Now watch. Use some color here. Square root of 4, 2. I get a 2 out. Oh, here's a 2 times a 2. What's the square root of 2 times 2? I get a 2 out. Oh, and what's the square root of 9? I get a 3 out. Is there anything left in? Well, look, you could write the square root of 0, but guess what the square root of 0 is? 0. It's just gone. It's not there. Square root of 0 is 0. And it's, oh, that would be dumb. Square root of 0 is 0, and then everything would be gone. All right, if you were going to write anything, it'd be the square root of 1, and the square root of 1 is 1, but we don't even write it. Once everything comes out, you just don't write the radical anymore. So what's the answer? 2 times 2 is 4 times 3 is 12, and that is, the answer is 12. By the way, 8 times 18 is 144. What's the square root of 144? 12. Now for something like that, that seemed easier, but it's not, because look at 17. So again, it's a square root. I'm looking for something times itself 2 times. All right, let's do the numbers. Here's a 2 times 10. And I could do the 10, but I'm already looking at my 63. 6 times 9. Actually, I'm going to need to do the 10. Okay, I see it right now. 10, 2 times 5. All right. 2 times 2, I get a 2 out. Square root of 9, I get a 3 out. Now I have 1 5, 1 2, and 1 3 left. I don't have 2 of anything else. It's going to be stuck. Look at my a's. I have 2 a's. What's the square root of a squared? A. This one's going to stay. It's going to be stuck in there. Look at my b's though. Here, let me use black. I have 1 here. I have a second, and then there's the other 3, right? There were 3 here, so there's 1 and 2 more for 3. So notice this. Whoops, put that back where it's supposed to be. Actually, it was right there. Okay, come on, get the right pen. All right, so what's the square root of b squared? B. Now, let me use orange here. What's the square root of this b times that b? B times b is b. What's left in? It's a square root, no index. 5 times 6 is 30. I still had the a from right there, and that's it. All right, so 2 times 3 is 6. A, b squared, times the square root of 30a. Let me check that, make sure I didn't miss anything. And sure enough, 6ab squared times square root of 35. Oh, brother, that's embarrassing, isn't it? Yeah, now I'm with you. 6 times 9 is 54. 7 times 9, it's a 7. Is a 35, brother. Were you drinking the Kool-Aid? Did you catch that? All right, I hope you caught that. Brother, math times tables. Woo-hoo. All right, you'll be old one day too. All right, here we go. Oh, got to go back here in the bottom. Actually, let me just get rid of my shade so I can scroll up. Okay, so let's do the last 3 problems. Again, it's really important that you get good at these. Oops, I just noticed I shouldn't have given you 19 and 20. I don't think. Let me check real quick, which is fine because you haven't gotten the assignment yet. Yeah, that one's these we're not going to do, right? So what I'm going to do, last one is 18. Okay, notice the index, cube root. You always got to notice the index. I have to look for 3 of something. Let's do my numbers first. This is a 3 times 3. Do you see how I now have 3 3's? Cube root of 3 times 3 times 3 is a 3. I get a 3 out. My a's. I want to do a cubed. See, I want 3 of them to match the index. And then I have a squared, right? Because there's 5 of them. So a cubed is a. And notice these 2, and that one is 3 more, and I get an a out. Okay, cool. B's. Now look, I've already used up 2. There's a b times a b cubed. Those 2 and that 1 are 3. I get a b out. And these 3, I get a b out. And look, there's nothing left in, right? So 3, a squared, b squared is number 18. And sure enough, that's the answer. 3, a squared, b squared. All right, so that is the case. And this wasn't through 20 as the title said, at least the title in this video, only through 18. All right, real key that you understand how to simplify radicals. I hope this video helps you. Please email me with your questions and we'll get through this distance learning and try to learn as much as we can in the midst of these tough circumstances. All right, hope you have a great week.